Here we have a comparison between the definite integral and the indefinite integral. The definite integral gonna has limits on the integral, and to solve the definite integral we're gonna use the fundamental theorem of calculus. So it can be the definite integral from a to b f of prime of x dx equal to a and b evaluated at the antiderivative. That gonna be f of b minus f of a, and the resulting gonna be a number. In the past, to evaluate the definite integral, it's just the area under the curve, or we take the definite integral and plug it into a calculator to estimate the value of it. Now, for the indefinite integral, note that there's no limits on the integral. And for the solution, when we take the integral of f of prime of x dx, it again has two solutions. Again, it has a general solution and a unique solution. A general solution in form of f of x plus c. Remember, f of x called the antiderivative. And here we have f of x plus c. With this called a family of functions or family of antiderivatives, since here c can be any number. The second solution will be a unique solution, that is f of x, which is the antiderivative. Here we want to find the integral for a, b, and c. Note a, it's gonna be definite integral, b and c are indefinite integrals. B gonna be using a general solution, and C, the solution gonna be a unique solution. For A, we have the definite integral from 1 to 2x dx. This is a definite integral since we have a limit on the integral, that is 1 and 2. So, to solve this integral, I'm gonna use the Fundamental Theorem of Calculus of TC. Remember the Fundamental Theorem of Calculus, the definite integral from a to b f of prime of x dx equal to f of b minus f of a. Remember, on the right, f here, it's the antiderivative of f of prime of x. Here we have this function 2x. This is f of prime of x, so we're gonna ask ourselves this question. What is the function that when we take the derivative of gonna result in 2x, and that function gonna be x squared. So the derivative of x squared is 2x. Now we are ready to apply the fundamental theorem of calculus. So the definite integral gonna be 1 to 2x dx, and the antiderivative function gonna be x squared, and then you're gonna evaluate it at 1 and 2. So the resultant will be 2 squared minus 1 squared, and that's gonna be 4 minus 1, which will result in 3. Note the solution of the definite integral is just a number. For part B, we have the indefinite integral 2x dx. Here it's indefinite because it does not have any limits. Note here what type of function that if we take the derivative of, it's gonna result in 2x. Again, that answer gonna be x squared. Again, when we take the derivative of x squared, gonna be 2x. But notice something in here. When we take the derivative of x squared plus 1, the derivative also will be 2x. And also the same thing apply for x squared plus 2, and so on, since the derivative of a constant is just 0. So we're gonna write that in general. The derivative of x squared plus c is just the derivative of 2x. Therefore, the indefinite integral of 2x dx is going to be x squared plus c. Why c? Because c can be any number. So to make it more general, we just have gonna write it in c. Note in here, x squared plus c called family of functions or family of antiderivative, since c can be any number. For part C, we have the indefinite integral 2x dx, and then we are giving f of 0 equal to 0. Note we already solved the integral of 2x dx from part B. It's gonna be x squared plus c. X squared plus c is the antiderivative. So using the given of 0 equal to 0, this will help us to solve what's the value of c. So here c gonna be equal to 0, therefore the antiderivative of x gonna be equal to x squared. Notice in here, this is called a unique solution since we only have one value of c. Here c is 0. On the other hand, for part B, the solution here is called a general solution because we use c and c can be any number in here. It's not unique.